All right, let's start talking about these. Let's talk about number 2 first. So do my bases match? No. Do you think it would be possible that I could think of a base like 2 or 3 or 4 or 5 that I could convert both of these to? Yeah. What base seems most likely here? I've got a 9 right here. So what power would I take 9 to get 1 over 27? Pop into your calculators 9 to the 3rd power. 729. Okay, so I can't do 9 to the 3rd. What's the first thing you notice about this left-hand side? It's a fraction. So what do we know our power has to be? We could do 3 to a power. So 3 to some power. Well, do 3 to the 3rd power and see what you get. I think you're on the right track. You get 27. I want 1 over 27. How do I make it a fraction? Negative. So 3 to the negative 3rd power would give me this. So I'm going to rewrite 1 over 27 as 3 to the negative 3rd power. And then I'm going to bring down the rest of that exponent, x plus 13. Equals. This does not match this base here. But can I rewrite 9 so that it is a base of 3? 3 squared would give me 9. So I can rewrite that 9 as 3 squared and then bring down the rest of that exponent, which is 5x. Are my bases the same now? Yes. Once my bases are the same, what does that mean about my exponents? How did we get the 3 to the negative 3 equals 1 over 27?
No, like equals the 3 to the power 2.
Oh, so what I did here, this fraction right here is exactly the same as this. So all I did was rewrite something that has the same value, 3 to the negative 3 value, 3 to the negative 3 has the exact same value as 1 over 27. So I'm just bringing down my original equation, but doing some replacements with things that have equal value. 9 is exactly the same as 3 squared, so I can rewrite those things. Kind of like how you can exchange money. It looks different, so my first grade daughter would tell you, that's not the same amount. She's like, that's 10 dimes, and you have $1. We don't have the same amount of money. And I'd say, yes, you do. Does that make a little bit more sense? So we're just doing this even exchange here for those pieces. Once we know those bases are the same, what else do we have that we can work with now? What else has to be the same? The exponents have to be equal. If the bases are equal, then my exponents are also equal. So I have that inside green exponent of negative 3, and then we have that outside exponent of x plus 13. I'm going to have to distribute that. So I need all the exponents on the left. It is going to be equal to all the exponents on the right. We have that exponent of 2 that's in green. And we have that exponent of 5x that's outside the parentheses in black. When we have an exponent inside the parentheses and an exponent outside the parentheses, we multiply them together. So I'm going to bring my work around here. And we're going to distribute those pieces. So negative 3 times x plus 13 equals 2 times 5x. I know when I distribute this negative 3 to x, excuse me, I know that gives me negative 3x. What happens when I distribute here to the negative 13? Negative 39 equals, and now I have to multiply these together. What is 2 times 5x? 10x. The goal of the problem is to solve for x, to get x alone. Where is x right now? It's on both the left side and the right side, correct? I need the x's on just one side. So I need one of my x's to cancel out. If I picked this one, I was like, I want this one to cancel. What would I have to do to this side of the equation to make a negative 3x cancel out? Add it. So I'm going to add 3x to both sides. So I would have negative 39 equals 13x. Last step I need to take to get x all by itself. We're going to divide both sides by 13. What is negative 39 divided by 13? Negative 3. Very nice work. All right, let's go and talk about number 1 now. We didn't quite get to doing an example like this in class yesterday, but we did talk about the formula that we would use. We had this formula. Does anybody remember what that capital A stands for? What does that capital A represent? What did you say?
Annual interest.
Our interest is going to be part of the formula, but that's not what the A stands for. The amount, yes. This is going to be the amount of money in the account. What does this capital P mean? What did you say? Principal. Principal spelled with an A. What does principal mean if I break that down just into normal English? Starting amount. What does the R stand for? That's our rate. So we go looking for a percent in our problem. It's going to be R percent. We divide that by 100% to get it in its decimal form so that we can use it. What does T represent? Time. And then that just leaves this N, which I see in 2 different spots. Means the same thing in both spots. Yep, number of compoundings in a year. So we call this the compound frequency. How many times in a year is it getting compounded? All right, so let's try to substitute in to write our function rule. In a function rule, we will leave A and T in the function. We're not going to substitute in any values for A or T here. So I have A equals Do I have a value that I could substitute in for P, for the principal? 3,000. This was the deposit amount. So that is my principal, that's P. That's the starting amount. And then I've got parentheses. It's going to be 1 plus, and then I have this fraction. What goes on the top of the fraction? 3.8, but that has a percent sign in it, so what do I have to do to it first before I can use it? Divide it by 100. So 3.8% divided by 100%. That makes my percent signs cancel, and it's going to leave me with just a decimal. 0.038. This is R. So that goes up on the top of my fraction. 0.038. What would go on the bottom of my fraction? What'd you say? 100? Well, what does it tell me? How many times in a year are they putting interest in this account? Annually. How many times in a year is annually? Once. One time in a year. So I put a 1 here, and I put a 1 here. Times T. That is my function rule. How much money will be in the account after 4 years? What new information did they just give me in Part B that I can use now? Yes. So only in Part B. Part A is just write the rules, so we're just going to leave it like that. So now, sub 4 in for T. And this is where our calculators come in handy. So I have A equals 3,000, and then parentheses, 1 plus 0.038 over 1 to the power of 1 times 4. What is 1 times 4? 4. So what I'm really saying here, what I'm going to type into my calculator, just has this to the power of 4. Grab your calculators out for me. We're going to type this in. Do you have your bell work page, hon? Do you have your bell work page from yesterday? If you don't remember where the fraction key is, please let me know. Yes, that needs to be an exponent. So you have to use this button right here to make it an exponent.
How do I make it
Not erase everything? Okay, so if you go back down to where you were.
I think it's already gone.
Oh no, I could have shown you how to do it. I'll show you next time. Okay. Is it more or less than our starting amount? More. Is it $1,000 more? Are we up to 4,000? Okay, so it's still 3,000 something, and we're talking about money in the account. So 3,000, and what are the next couple digits? 482. Then we have our decimal point, right? And then since we're talking about money, how many places after the decimal point do I want? 2, just like when you buy something. So what are the 2 numbers after that decimal point? You said 60?
Yeah, 66 would be like
So we need both of the numbers. 65 or 66, depending on how you round it. If you're off by a penny from me, I'm not going to take off points. So 65 or 66 I would be fine with, either one of those. Let's go practice a couple more problems like this. I got 2 practice problems for us today. We are going to finish up before the end of class, and I'm going to give us the remaining time in class to do corrections on your test. If you want to do corrections on that, if you're wanting to retake it, you've got some in-class time to work on those corrections. If you are not wanting to retake your test, if you are happy with the score that you got, then you can work on the 7-2 homework, and I'll put that up on the screen. That one is in McGraw-Hill. All right, so I'm in your notes packet, the 7-2 notes packet.
Can I use the restroom?
Absolutely. I'm on that very last page in the 7-2 notes packet. Does anybody need an extra copy? This is the page where we wrote down several of the different values for n. We didn't write down every single value for n, but remember, n is how many times in a year they are compounding it, or how many times in a year are they going to add interest to that account. All right, Luciana deposits $1,700 into a savings account that pays 1.8% annual interest compounded monthly. I want to pause right there. Compounded monthly. So what will my n value be? Whenever I see the word compounded, it's going to tell me my n value. How many times in a year, if they're compounding it monthly, how many times in a year will they add interest? 12. What is the starting amount of money? What is the principal? 1,700. So here's P. What else are we going to need? The rate. Where do I go looking for the rate? What symbol next to a number do I need? Percent. But before I can actually use it in my equation, what do I need to do to it? Divide it by 100. 1.8% divided by 100%. So my percent signs disappear. 0.018. This is the value for R. Is there any other number here that I have not used? The 5 years. What are they telling me with 5 years? The T, the time. All right, so our formula for compound interest, capital A equals capital P times 1 plus R over N to the power of NT. Let's substitute in what we know. Which one of those letters do I not have any information about? A. So A equals, what do I put in for P? 1,700. In the parentheses, 1 plus, what are we putting in for R? 0.018 over what? Over 12. Close my parentheses, and then the exponent is going to have what in it? Yes, so what numbers do I need to put up here? 12 and 5, and what are we going to do with the 12 and the 5? Multiply them. Before I pop that in my calculator, what is 12 times 5? 60. So into my calculator, I'm going to put 1,700, and then I'm going to open up parentheses. 1 plus, and then I'm going to use my fraction key. 0.018 over 12, close my parentheses, and then I have to hit that exponent button. This is the one just above the x squared key. It looks like the top part of a triangle, but it's just missing the bottom. This is how you get your calculator to do an exponent. And we are doing this to the power of 60. More or less than we started with? More. Is it up to 2,000 yet? No, so it's still 1,000 something. But it's more than 1,700. 1,859. And how many cents? 97 cents. Always two numbers after that decimal. I want you guys to try the check down at the bottom on your own. And then we will go over that together here in about, I'm going to give us about 2 or 3 minutes to do that. Yes. Yep. Mm-hmm.
What is this percentage where he gave me back this?
So what that's saying, and that's so strange that it does it at that point. That's saying that this is going to be behind a decimal point. So you would put a decimal point down. You're going to do 2 zeros, and then this would be the third number.
Okay.
So it's going to be all zeros before it, and then it tells you like where it falls in line after the decimal. Does that make sense?
Maybe like something like this or like.
Nope. This is the third number in line.
Mm-hmm.
So you have 1, 2, 3. You put it as the fourth one. It's so weird. There's always one less zero than the number there.
So, sorry, I'm confused.
That's okay. So it's going to be 2 zeros,
Mm-hmm.
and then that number.
9 or?
Yep, 9.
Okay.
So do you see how when you write it out like that, that one's the 1, 2, third one in line?
Mm-hmm.
That's what that's telling you there.
Oh, okay.
Does that make more sense?
Yeah.
Okay. 424. Yes, that's exactly right. Let's get through this first. I need you to work on this problem first, down at the bottom of the page.
So like, I like this in the paper, trying to find this.
What'd you say?
Um,
This number right here is part of this problem. Down at the bottom is its whole new problem.
Okay.
I want you to do it like we did this one, but this down here is a whole new problem. New person, new money, new interest amount. That's exactly correct, yes. Can't hear you.
How do we check it?
How do we, no, this is the check problem. This is to check to see if you understand it. So you're going to do this one exactly the same way that we did this one, but with new numbers. This isn't checking the previous problem.
Just like you did with that, we did it like this, like with that.
Yeah, you're going to do this problem exactly the same way we did this problem. But you're going to have to find the p amount, you're going to have to find the n amount, you're going to have to find t, you're going to have to find r. Because they're all different down here. But it follows the same pattern. All right, let's see what we've come up with. Tell me from the story up here what the different numbers represent in the formula. Pick out any of the numbers and tell me what they mean. 5 is 500. Sorry, I didn't hear you say 500. 500 is P. This is our starting amount. Perfect. What else can we get from the story? 0.9% is the rate. So 0.9%, we have to divide that by 100%. So my percent signs cancel out. I know that that percent already had a decimal in it, but it also had a percent sign after it. So once I get rid of the percent sign by dividing by 100, what is just the decimal that's left over? 0.009. That's our value for R. What else can we do? You said N is how much? 24. How did you get that? I like it. Compounded twice a month. So 2 times each month means that N is 24. There's 12 months in a year, and they're going to do it twice each of those months. Anything else? 25 years is T. All right, so I'm going to grab that formula that we had. Again, I do not expect you guys to memorize this formula. We've had a couple formulas already, though. So you will have to know which formula to use. I will give you the formulas on the test, but you'll have to be able to match the problem to the right formula. And we will talk about that when we have our review days, because I'll have the formulas up at the top, and we'll look at each of these problems and how we know which to use. All right, so A equals P times 1 plus R over N to the power of NT. From what you guys told me, this is going to be 500 times 1 plus 0.009 in my numerator, 24 in my denominator, and then I'm going to have 24 for N times 25 for the years. And I can pop that whole thing in my calculator and get what? $626 and 13 cents. Double check that on my calculator too to make sure I get the same thing. Yep. If you round it up to 14 cents, I'd still count that as perfectly correct. If you're off by a penny, that's fine. If you're off by 2 pennies, I'm probably not going to cry about it. If you're off by more than that, then you probably did something wrong in the problem. I want to talk about what the function rule looks like, because on our e-learning day, which is Thursday this week, you guys won't report to school. You are going to have a take-home quiz, and it does ask for the function rule. So the function rule looks exactly like what I did over here, but you're going to leave t in the formula. We're not going to substitute the number in for t. So function rule, we leave a and t as letters in the formula. So my function rule would be A equals 500, and then 1 plus 0.009 over 24 to the power of 24 times t. So we can just write that as 24t. The reason we often want things written as a function rule first is because now I could ask you for any year. I could say, hey, how much money is Aisha going to have in her account in 50 years? You can use this rule and just put 50 in the place of t now. Or I could say, how much is she going to have in 5 years? And you can plug 5 in the place of t. So I'll ask for the function rule first on problems like this, and then I'll give you a number to sub in for t in the second part of the question. Very similar to the way our bell work was structured. All right? Do you guys have any questions about the stuff that we've done today? Because this wraps up 7.2. Biggest, most important pieces would be the front page, like what we did on the bell work, and this third page, like what we did here and what we also did on the bell work. Those are the biggest, most important ideas. That the back of the front page is a nice to know, not a need to know. Front page and third page are need to knows.